everyone, we're going to work on compound inequality practice. We're going to use the number lines below to identify the intersections, also known as an and inequality, in the left column. And the union, take everything, you can think of this as take everything that is graphed, but this is specifically called a union inequality or an or inequality in the right column. First, some notation reminders. These are just reminding you that if you are going to graph something where x is less than or equal to a, then it would be a bracket opening to the left where you would define a. Similarly, if you have x is greater than or equal to a, that would be an a with a bracket opening to the right. And then on the other side here, we have x is less than a. That would be an open parenthesis or a closed parenthesis, or you could say a parenthesis opening to the left. X is greater than a would be a parenthesis opening to the right. So just as a reminder, that's the notation we're going to use on this video. So let's go ahead and get started. On the left, we're using intersections. We need to find the intersection. Another way you will see this is an and inequality. And the notation symbol is this upside down U, and I kind of like to think of it as an A because it starts with and I just don't put the horizontal bar there. That's a secret. That's how I remember the notation there. The other side here on the right will be unions, inequalities, and another way you will see this described as an or inequality, and this has a U to unite the pieces that are separated. Now, sometimes they're not separated. Sometimes they overlap and you take everything that's listed on the graph. But if there are ever any gaps in your interval, you have to use one of these union symbols to say that there was that gap there. Okay, let's get started. The basic idea here is to find out where there are intersections and then list the interval notation for that interval. I'm going to use a highlighter to define where that interval would be. We have an interval between A and B. X is between those two pieces. It doesn't include A and B, so we have parentheses here. Now, if I were to think about the overlap between the two graphs, if I were to graph them on the same number line, it would look something like this. We have a number line. We list an open paren at A, a closed parenthesis at B, and the interval is between those two. That would be a graph of the intersection of those two values, and the interval notation would be open parenthesis A, comma, B, closed parenthesis. Now let's look at the or situation. We notice that we have the same exact thing graphed here, but in this case we are asked for an or, a union, not an intersection. A union means you are uniting the A inequality with the B inequality, and you take anything that is true, not just the overlap. So this time we're going to again graph a number line, and we're going to draw A on the number line, moving to the right, and I'm going to highlight that in yellow. And then I'm going to draw another inequality on the number line, B, moving to the left, and I'm going to highlight that in another color. Now look, there is overlap. See how it changed to green when I used the blue highlighter? That's actually the intersection where it changed to green. That's this part right over here. That's the green. That's the overlap. That's cool, but that's not what we're asking for in an or a union scenario. We are uniting both pieces, and so anything there as a highlight is taken. We keep it. So this interval is negative infinity to infinity. Now let's take a look at the next one. In this scenario, again, we have an and inequality. We have x is less than a and x is greater than b. Notice that for an and, we want the intersection. We want to know where the overlap is. So let's go ahead and graph a third number line. We'll graph the two inequalities together on the same number line. B opens to the right, A opens to the left. And notice I'm just tracing down from the actual original graphs. And if you look at this, you can see that there is never any overlap. They never intersect. They never touch each other. It's kind of like the truck drivers who drive in different directions. So in this scenario, we say D, N, E. Now let's look at the OR scenario. Same exact values, same exact graphing. They did change A and B around, but notice that the intervals look exactly the same. So now what we're going to do is once again graph a third number line where we graph both of them together. In this scenario, B opens to the left, A opens to the right, and there is this gap in between where neither one has anything going on. So we'll go ahead and graph or highlight the intervals A and B. A is highlighted in blue, B interval is highlighted in yellow, and we need to take anything that is graphed. So I will give the interval from negative infinity to B, close parenthesis. There's a gap, so I put a union. It's uniting the two pieces. Open parenthesis A, comma, infinity, close parenthesis. So this is a way to compare what your solution would be for these same intervals, but when you're asking for an intersection or a union.